So the array is now sorted. So I'm going to call the binary search, and I'm gonna return a boolean. It basically returns true or false depending on whether the number that the user is looking for was in the array or wasn't. If it was, it returns true. If it wasn't, it returns false. So the boolean binary search, that's gonna be the name of the function. It needs two things. It needs the input, the value that the user inputs and is looking for. So I'll just call it entered value, and it needs the array, which is the same array that we are passing here. So but this time it's going to be already sorted, so we can perform the binary search. So it's gonna be an integer array, which I'll just call array again, with the number of elements as its size. And that is our binary signature. I'm just gonna copy paste it and place it right here. And I'm not gonna do I'm just gonna leave it as an integer without the actual names. Well, array. I guess we can. It doesn't matter. We can leave it. If you already know the names, you can pass them in the signature. That's okay, I think. So why not? So we pass in the array and we pass in the input from the user. So now we have the number to search for and the array to search in. So binary search works that you kind of cut everything always in half. Because the array is already sorted, you know if the number is less than what you look. I mean, if the number is less than what you're looking for, then you move one direction, and if it's greater, then you move the other. So let me just kind of quickly demonstrate here. Let's say we have the array sorted, and it's 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. These are the values. And let's say we are looking for number 8. So it comes over here and it says, all right, cut this array in half. So it comes to 5. That's the half of it. And it's searching for 8. So it says, is 8 greater or less than 5? Well, it's greater. Since it's greater and the array is already sorted, you know that greater numbers are to the right from 5. So it will search only this portion of the array. Or it knows that, okay, it must be in this half of the array. So what it does, it cuts it in half again. Now it's 1, 2, 3, 4, 5, 6 elements. So it comes over here and let's say it cuts it to 7. Now it says, all right, is 8 greater than 7? Yeah. So again, it knows it has to be to the right from 7. So it knows it's in this position somewhere here. So now it comes, cuts it in half, goes to 9 and says, all right, 8 is less than 9. So it knows it has to go to the left. But it doesn't go all the way to the left because it already searched all these. It already knows that this is not the portion of the array where the number is because we already searched there. So it only searches here, and now the only number to beat is the next one to it. So this is how this binary search operates. It cuts everything in half in order to kind of zoom in, so to speak, onto the number that you are looking for. And if it's not there, then it will return false. Our function will return false over here. So I'm going to create a few variables. I'll just call it first. That's gonna be the position that we will need to kind of keep in mind or keep track of. I'll call middle because we are cutting it in half, and last. And last, we can do the number of elements, because that's basically our -1, of course, because we are having 18 numbers but 17 indexes because we start from 0. So maybe I misspelled that. Yeah, so our last is basically saying, okay, this is our last number. First and middle we don't have to initialize it, but we need to remember what the size of the array is, because we are going to be obviously doing some loops. And I'm gonna create another position, another value, and I'll just call it position, integer position. I'll initialize it to 0, I guess. Now the loop itself can be a while loop, and we will be looping. How do we know when to stop when we didn't find anything, if the number doesn't exist? Well, if the first is less or equal to last, then you can keep looping. If it's not true, if first becomes greater than the last, remember we're cutting it in half, so last will change. Let's say last will be, you know, somewhere here or whatever, depending on the number we're looking for. But if our position of the starting position is past that, then we know we didn't find anything. So this is our condition. If while the first is less or equal to last, we still can keep looking. Otherwise, we will just return false. The first thing we need to do when we're looking is determine the middle. What is the middle? Well, it's the first and the last divided by 2. That's so at the beginning, when we come, remember our last equals 17, our first equals 0, so 0 plus 17 divided by 2, well, you get 8.5, but of course, since this is an integer, you get 8, because it simply truncated it and it skips only the whole portion of the number, which would be 8. So middle equals first and last divided by 2. So this is calculate the midpoint. Now we can do simply determine whether the midpoint is the value we're looking for. So if the array with the index of middle, that's the midpoint, if it equals the entered value that is being passed as the input from the user, then we found the number we were looking for. We can return true. Yeah, we found it. Now else if, and the else if is if the array with the index of middle, if our middle is greater than the entered value, then we are moving, we're moving the last position to the middle. But not, since we already checked middle, we don't have to check it again. We can kind of speed it out and do middle minus 1, like the number 1 before that, because we already know the number in the middle was not the one we are looking for, because we already checked it over here. Is it equal to the entered value? No. So we already know it's a wrong value, so we don't have to check it ever again. We can go the one before that. Else, in other words, if the middle is less than entered value, then we move the other direction, which would be obviously the middle middle plus 1, but not for the last, because we are moving the other direction, so it's gonna be the first instead. So it equals the middle plus 1. All right, so let's let me get these numbers. And I'll just copy paste them over here so we can kind of see what's going on. All right, I'm gonna change the numbers. Let's just make it like 11 and 22 and 33 and 44 and 55 and 66, 77, 88, 99 and 100. And that's because I don't want you to confuse the indexes with the actual values of these numbers. Okay, so it comes over here, middle, first plus last, divided by 2. So first is, we're talking about indexes here, right? So first index is 0, last index we have the number, so it's 9. 0 plus 9 is 9, divided by 2 is 4.5, meaning the index of middle is 4 because it's an integer. So the let's say we're looking for the number of 88, right? So it comes and does the middle equals first plus last divided by 2, meaning that the middle now equals has the value of 0, 1, 2, 3, 4. This is our middle point at the first iteration. So it will come over here and it asks, all right, is the value that has the index of 0, 1, 2, 3, 4, 5 equal to the value we're looking for? In other words, it says, is 55 equal to 88? No, it's not. So now it asks, okay, is 55 greater than 88? No. So it comes to else, and because 55 is less than 88, it changes this condition now. So first now will equal middle plus 1. Middle is the index, so it's 5. Okay, so that's the index of 5 plus 1, meaning it's 6. So our starting position now equals index of 6, basically meaning that's the next number after that, which is 66. Remember, so this is now 6. So it comes over here and says, all right, first plus last, first is now 6, plus last, which is still 9, because that's the number of elements minus 1, that didn't change. So 6 plus 9 is 15, divided by 2 is 7.5, meaning it's 7, because again, it's an integer. So our middle position now equals 7, right? So it's 0, 1, 2, 3, 4, 5, 6, 7. In this case, it comes over here and says, all right, is the 88, because that's the index, equal to 88? And it says yes, it is. So we found it really quickly. So let's assume it was 99 we were looking for, not 88. So it will ask, is 88 equal to 99? No. All right, is 88 greater than 99? No. So again, it comes over here and it says, okay, since this is the index of 8, now we will add 1 to it and move basically to 99. So that's gonna be our next iteration, and it will find it there because obviously we have only 2 numbers. So I would need probably a bigger array to explain it, but let's say we go the other way around. We're looking for 22. So again, this is it comes over here, it says 55 is the middle, and it comes here, 55 is not equal to 22. Is 55 greater than 22? Yes, it is. So now it comes over here and changes the last, because we know that we are moving to the left. 55 is greater than 22, so we have to move that direction to the left. So what it does, it changes the last, which by now to the middle, which is the index of 5 minus 1, which would make it the index, the one before that, which would be 44. So this is the portion that it would be now searching. So now we have our middle equals first plus last. Again, our last changed. Now our last is 4. Our first didn't change, so it's 0 plus 4 divided by 2, so it's 2. So it's 0, 1, 2. So this is our new index. This is our new middle, even though it's not exactly middle, because but that's how it calculates it, because we're only dealing with integers. So now it comes over here. Is 22 equal to 33? No. Is 33 greater than what we are looking for, which is 22? Yes, it is. So again, it changes last to the index before that, which would be 22. So now our index, our last, equals 1, because it's index of 0 and index of 1. So basically it says 0 plus 1 divided by 2. Well, you cannot really do that for integers, so it will be 1. And it will come over here. Index of 1 is 22, and that's the number we're looking for. Okay, so I hope it makes some sense. I'll just delete these comments. And so this is our really search method. Again, if it finds it, then we need to return true, and if it doesn't, then we have to return false. So if it doesn't find any of it at the end of the while loop, after the while loop, I'm sorry, we will return false. Because if it does find the number, it will return true over here, so it will exit the function all the way. If it doesn't find it, this return true is never executed, and it just simply comes to the end of the function and returns false. So all we have to do now is go to our main method and make the call to this binary search after our selection sort, because obviously the array has to be sorted before it can be performed binary search. And we remember we have our boolean number, a boolean value of true in found, so we can do an if statement. If found, which is true, which is set to true at the moment, so if it equals whatever, if the binary search returns, if the binary search returns true, then true will equal true, and that makes it a true. So that means that the value was found. So we can make the call to our binary search right here, and it expects the account number. That's the input from the user, which, by the way, we'll have to make. And it needs the array, the account array. So if this is true, then return cout something like the account, and we can actually write out what the number was. The account number is a valid account. And I'm just gonna copy paste the whole thing, well, the statement, because if it is not, then we will simply do the account number is not a valid account. Remember, our binary search returns true or false. Since found is set to true, we're basically checking whether true equals true. And if it is, then obviously we found a valid account, otherwise we found a wrong account, or we didn't find the account. But like I said, we need the input itself, so we will do cout first over here, something like please enter your account number, and we will do cin the account number to store it. So now that's really all we need as for the input. So let's see if it's gonna find anything, if it's gonna build in the first place, and if it's gonna find the input. So let's say we're looking for, let's say 9, which is there, and it says account 9 is a valid account. All right, let's do 1, which would be the first number, and yeah, it is valid account. So let's do 18, which is the last number, because I remember the array is gonna be sorted by then, by after the input is entered, and it's a valid account. Let's do some invalid account. Let's just do, I don't know, 123, and it says it is not a valid account. So let's do a 0, and it says not a valid account. So really, that's all there is to it. We just have to kind of, especially for this binary search, you have to realize that you need the middle position and what direction within the array you're moving, whether you move in to the left, and if you move into the left, then you have to remember the new ending position, because you don't want to go all the way to the end here. You want to keep the ending position, which is basically the number that you the current middle number would become the new ending position. If you move in the other direction, if you move into the left, then the middle position will become your starting position, right? So you have to, if you look at it, okay, this is starting position, this is ending. So if you start from 16, that's the ending position. If you start from 16 this direction, then it's the starting position. All right, so that's what you have to keep in mind in the binary search, and you know, just practice with it a little. You should definitely not just copy paste the code. You should actually type it yourself, and maybe you know, try to do it yourself completely after you, even if you mimic this, try to do it yourself, you know, from memory, because this is just quite a common, you know, quite a common search, quite a common algorithm. All right then. Well, I hope you liked it. I hope it helped. If it did, please leave a like. Please share with your friends. Please leave a comment. And I will see you in the next video. Take care.